Okay, welcome everyone. This is just the example portion of 7.1 where we're doing trig identities. So in this case here, we're just simplifying. And in order for us to simplify, we have to express everything in terms of sine and cosine. Right? So tangent equals sine over cosine. That's all I did. And here, my next step would be to combine the two and make this sine squared theta over cosine theta. Okay. And then to get my common denominator of cosine theta, this first term, the cosine theta, I need to multiply this by cosine over cosine. Right? So cosine times cosine is cosine squared theta plus sine squared theta. Well, cosine squared plus sine squared, that's just equal to 1 over cosine theta, which is secant theta. Okay? So we're essentially just putting it in terms of sine and cosine and running through the steps. Okay, and simplifying, canceling, getting the common denominator, all the algebra skills that we need. Okay? So the second one is this. I see two fractions. Everything is in terms of sine and cosine. So I'm going to get the common denominator. For this first few, I'm going to split it up like that first so that I can show you guys what we're doing step by step. Okay, that's my common denominator. Cosine times 1 plus sine. Okay, so in this first fraction, sine over cosine, I need to multiply both top and bottom by 1 plus sine. Right? So I would have sine theta times 1 plus sine theta. In my second fraction, I need to multiply this by cosine over cosine. The reason why I'm doing that is because of my denominator, right? This denominator here now becomes this denominator here. Okay? So that's going to be cosine squared theta. So my next step would be to put it all under one fraction. Okay. And I'm going to distribute the sine out here. So sine times 1 is sine. Sine times sine is sine squared plus cosine squared. Yeah. That's what we did, right? Now, remember one of our tips. Whenever I see a trig ratio or trig function squared, I'm going to think about those Pythagorean identities. And I see two of them, sine squared theta plus cosine squared theta. This equals 1. Right? So sine plus 1 over my denominator of cosine, 1 plus sine. Now, sine plus 1 is the same thing as 1 plus sine. So those two cancel out and make 1 over cosine, which is secant. Okay? This one here, turn everything in terms of sine and cosine. So my numerator is 1 over cosine. My denominator is 1 over sine. Keep, change, flip. Change and flip it. So this becomes sine theta over cosine theta. What is sine over cosine? Tangent. So that's my answer. Okay? My fourth example we have here. I can do this multiple ways to simplify. I see something squared, right? Tangent squared minus secant squared. So what is that Pythagorean identity? Tangent squared plus 1 equals secant squared theta, right? So in order for me to simplify, I'm just going to substitute tangent squared plus 1 for secant squared theta right here. Okay? So I have tangent squared theta, this one, minus tangent squared theta plus 1. Distributing out the negative, that's negative tangent squared plus tangent squared, or plus tangent, or no, I'm sorry, it's not tangent, minus 1. Dropping this one down. Tangent squared minus tangent squared, they cancel out, leaving negative 1. Okay? Questions? No? What is 1 plus tangent squared? Again, there is that trig function squared. So think about your Pythagorean identities. What is 1 plus tangent squared? Secant? So this is cosine squared times secant squared, right? So you can go through the steps of making everything in terms of cosine and sine. So this would be cosine squared over cosine squared, which is 1. Okay. This one here, turning everything into sine and cosine. I just gotta, secant is cosine minus cosine over sine. getting the common denominator of cosine this would be 1 minus cosine squared theta. Right? And I know 1 minus cosine squared is sine squared theta over cosine squared theta all over sine theta. Keep, change, flip. Keep it, change it, and flip it. So one of the signs cancels out with the sign on my denominator. So I have sine over cosine squared. Oh no, this is not squared. Sine over cosine, which is, what is sine over cosine? Tangent. Okay. All right. This one, sine x times 1 over cosine x all over tangent x, but I'm just going to simplify this. Sine x over cosine x, which equals tangent, right? So I have tangent x over tangent x, which is positive 1. Okay. Doing the same thing. Cosine x times 1 over cosine x. Simplifying this, this is cosine over cosine, which equals 1. So this is 1 over cotangent x, which is tangent x. Nice and simple, right? Okay. Next one, I have this. I'm going to turn the bottom in terms of sine and cosine. That doesn't help. So I am going to turn cotangent in terms of cosine and sine. So this would be sine A plus cosine A all over sine A all over sine A, or 1 over sine A. Right? Keep, change, flip. Keep the first fraction. Change the division to a multiplication and take the reciprocal of the other fraction, the second fraction. So these sine A's cancel out, and you are left with sine A plus cosine A. Okay. This next example, we have cosine cubed of x. plus sine squared of x cosine x, right? Now this is just an algebraic term, okay? If you think about what we can factor out, what can we factor out? Nope. Huh? Cosine. Yeah. There's two terms here, class. This one and this one, right? Terms are separated by a plus or a minus. Okay? So since there's a plus here, this is my first term, this is my second term. Okay? So I can take out a cosine because they are similar, right? They belong to both terms. So if I pull it out, I have cosine squared plus sine squared. What is cosine squared, sine squared? 1. So this one is just cosine. Yeah. We're just using basic algebra skills to get it. Okay. Next one. I'm going to skip this one. Okay. 1 plus sine y over 1 plus cosecant y. All right. Getting everything in terms of sine and cosine. This is 1 over sine y, right? Here in my denominator, I'm going to get the common denominator. Okay? So, rewriting my numerator, 1 plus sine of y over my common denominator here is sine y. So my numerator would be sine y plus 1. Any questions on that? On how I got that? You guys can take your time, but that's what it is. Okay? This here, common denominator wise, will be that. Okay? So if we keep change flip, 1 plus sine y, change and flip my second fraction. These sine y plus 1 and 1 plus sine y is the same. So they can cancel out. And we're just left with sine of y. Okay? All right. What is this mess? It's okay. I'm going to get the common denominator. Common denominator for all of this is cosine theta times 1 plus sine theta. Cosine theta times 1 plus sine theta. Okay? So in my first fraction here, what do I need to multiply by to get to this denominator? 1 plus sine y, right? So 1 plus sine theta times 1 plus sine theta My second fraction, how do I get from my denominator of this to this? Multiply by cosine. So I'm going to multiply cosine with cosine, it's cosine squared. Right? Everybody with me? Putting it all under one fraction, I have cosine 1 plus sine. You can FOIL this first one out. Okay, you can FOIL this one out here. Okay. Or you can just know the special form. Special form is 1 plus 2 sine theta plus sine squared theta plus cosine squared theta. Okay. And now I see this. I want to simplify more. What is sine plus cosine again? 1. So I have 1 plus 2 sine theta plus 1. So that's 2 plus 2 sine theta over cosine theta 1 plus sine theta. Right? We're good with that? Okay. In my numerator here, what can I take out? A 2. A 2? I didn't sneeze. I said a 2. Zing. Okay. Cosine times 1 plus sine. Now I can get rid of these 1 plus sines. And I have 2 over cosine, which is 2 secant of theta. Because cosine, 1 over cosine is the reciprocal of secant. 1 over cosine is secant. Okay. This one's a little tricky. Okay. I'm going to show you guys a new trick. All right. So don't get flustered. I am going to use the difference of squares. The difference of squares, you guys already should know, a squared minus b squared equals a plus b times a minus b. Okay? Remember that those guys are the conjugates as well. Okay, so if you guys hear me saying these words, that's what I mean. Okay, conjugates. Okay. So here, what I'm going to do is multiply this whole thing by the conjugate of my denominator. Okay. So now I have cosine x times secant x minus tangent x over secant squared x minus tangent squared x. How did I get this so fast? Because I just used my difference of squares, right? I have a plus b. I have a minus b, right? A plus b times a minus b. And now I just squared both and put a minus sign between them because it equals a squared minus b squared. I see a trig function squared, right? What is that? Secant squared x minus tangent squared x. That equals 1. So that just goes away as 1. Okay, so I'm just left with cosine x times secant x minus tangent x, right? Distributing the cosine out, I have cosine, and I'm simultaneously going to make everything in terms of sine and cosine. Okay? Minus cosine times sine over cosine. Cosine times 1 over cosine, that's just 1. Minus, these two cosines cancel out, and you have sine. Okay? Cool? That is where I'm going to end this lesson. All right? Next time, we're going to do proofs. So be on the lookout for that.